device or sensor. Precision, the ability of the transducer to produce the same output each time the same input is applied. So, minsan ay kahit pare-pareho yung ating ginawang condition, nag-iiba-iba ng konti yung ating output. That corresponds to precision. Sensitivity is the ability of the transducer to generate an output for a given change in input. Ibig sabihin, gaano kaliit yung increment or change ng ating parameter na masasense ng ating mga sensor or actuator. Range. It is the highest and lowest values the transducer is designed to measure. Example, may mga thermal sensor na ang kanyang range lang ay from 0 degrees to 100 degrees. What if we will need to apply it to a higher temperature like 300 degrees? So, hindi na natin magagamit yung sensor na yun. That covers the range. Span is the difference between the upper and lower values of the transducer is designed to measure. So, yung span is a smaller limit ng range. Mas maliit usually itong span because this is the design of your system. Linearity refers to the change in output compared to the change in input. So, ibig sabihin, habang tumataas yung actual temperature, tumataas din ba yung actual current produced by our sensor? So, that corresponds to linearity. So, let's take a look at this next video.
If you find this video interesting, then please like and share it. Also, leave your comments below. Don't forget to subscribe to our channel and click on the bell icon for notifications.
Let's start with the introduction. When we talk on a landline, we generate the sound signal. This sound signal is transferred from the speaker to the listener via a telephone cable, but not in the form of a sound wave. First, it is converted into an equivalent electrical signal at the transmitting end. This electrical signal then travels through the telephone cable, and then again at the receiving end, it is converted back to the original sound signal. A device that converts one form of energy to another is called as transducer. Thus, microphone, sound to electrical, and speaker, electrical to sound, are the two examples of a transducer. Depending on the principle of operation, transducers can be classified into basic types such as electrical transducer, mechanical transducer, thermal transducer, etc.
If you find this video interesting, then please like and share it. Also, leave your comments below. Don't forget to subscribe to our channel and click on the bell icon for notifications.
Okay, let's go to the first type of transducer, the sensor. So we have a different type of sensor. So sensors are the figurative eyes and ears of the control system. So there is a video here demonstrating the different type of sensor. So first is about different digital sensor and analog sensor. Let's take a look at this video.
Sensors are the figurative eyes and ears of a control system. In general, if you want to control it, you must sense it. Because the controls engineer is often called on to specify sensors and deal with sensing problems, sooner or later, we will all get more than enough familiarity with them. In this video, we are going to familiarize you with the sorts of sensors that we frequently use in industrial equipment. We intend this to be an introductory video for a new engineer just getting started, or for anyone looking for a general understanding of some general controls concepts. If you enjoy these videos, be sure to click like and subscribe so you never miss a new one. As a controls engineer, we often tend to see things from the electrical end of things. So in this exploration, we will look at two broad categories of sensors: digital sensors that return on-off signals, and analog sensors that return a range of values. Our first stop is digital sensors. These are by far the most commonly used sensors in the industrial world. So, what is a digital or binary sensor? In theoretical terms, we're referring to something that returns one or more bits of information per sensor. Initially, they were simple: a contact that touched another contact when something got where it was supposed to stop. In those old machines, this often meant 110 volts exposed for the operator to touch, or passing through the machine frame. Unsafe under any condition, and probably illegal in today's safety-conscious world. Later, these became a switch that flipped when something got to a position. These are referred to as limit switches, and are still in use. We use these sorts of sensors for anything that we divide into two states: on and off, true and false, is and isn't. For example, in position, full, empty, power on, and running. Let's look at a few examples of these kinds of sensors. First, as mentioned before, mechanical switches of various kinds are still around. Limit switches are still used in ugly, dirty environments thanks to their armor-plated construction. One big reason they've become less popular over the years is that they're huge compared to many of the other sensors available. Proximity sensors, very often called proxies, are used for detecting close metal objects using magnetic fields. In many environments, these have replaced limit switches in position sensing applications. Optical sensors have a much longer range than proximity sensors, but they are susceptible to dirt and other environmental and mechanical issues because they use light for sensing. We often use them where we are not picky about exactly where the target is, but we need to know it is there. Like boxes on a conveyor, where we don't care where on the conveyor it is, just that it's passing by. Capacitive proximity sensors are like a proximity sensor, but for detecting non-conductive materials. They are very sensitive to contamination, and historically have not been very dependable. Ultrasonic proximity detectors detect solid objects using high-frequency sound, but are very susceptible to environmental conditions and dirt. We don't use them often, but they can solve sensing problems nothing else can. In auxiliary context,
App 做描白金版100% 受訪醫生推薦，給剖腹產寶寶。
contact is a part of a relay. These tell us when whatever is controlling the relay has turned it on or off. A push button senses the operator's action. For now, that's all we'll say about digital sensors. Most controls are still designed around on-off signals, So these are the bread and butter of a control engineer's life. At one time, cars had no fuel gauge, and you had to have a reserve tank, a gas can, so that when you ran out, you could get to a fuel station. Now, cars all have fuel gauges, and we will next look at the sensors that make that possible, along with many other measurements that automation requires. An analog sensor is one that converts a variable physical quantity into a signal that the control system can understand, a voltage or current. By physical quantity, we mean temperature, pressure, humidity, distance, and speed, among others. There is a general category of sensor for each of these. Some sensors combine quantities, like temperature and humidity, or distance and speed, into a single instrument generating two signals. There are a few general categories of signals generated by these devices. For temperature sensing, the devices themselves produce either millivolt range signals, in the case of thermocouples, or variable resistances, in the case of resistance temperature detectors, or RTDs. Because of their higher accuracy and repeatability, RTDs are generally a better sensing element when we can use them. PLCs have cards that are specifically designed to handle both of these kinds of devices. The rest of the signal categories are converted locally into a more generally understood form of signal, either voltage or current, before being connected to the control system. If the temperature signals have to travel very far to the control system, we usually convert them like this also. The most commonly used standard today is the 4 to 20 milliamp signal because of noise immunity and other characteristics. And every type of analog sensor I have mentioned can generally be purchased in that type of output. We have just taken a whirlwind tour of the primary sensors used in almost every industrial control system. With these sensors, we sense everything from which buttons the operator pushes, to the height of liquid in a tank, to the pressure and temperature of steam in a boiler. These sensors and a few others, with their signals processed by hardware and software, control the industrial processes of the world. Make sure that you head over to realpars.com to find even more training material for all of your PLC programming needs. We offer many videos to assist you in learning PLC programming and landing that
Okay, I think we have covered much topic for now. So I will gonna stop discussing and presenting. So you may now use this remaining time to complete your laboratory experiment. So please make sure to submit until 1 p.m. I will stay online here if you have any question or concern, comments.